Welcome, students, to solving logarithmic equations with a single log. So remember this from Unit 9, you are going to need it again. So this is what we did to convert an exponential equation to a logarithmic equation. And now this time we're going to be going backwards. So we're going to be starting with a log equation and going that way. And I have already highlighted my bases, my argument, and then my exponent. So you may want to go ahead and do the same. So for these types of equations, when your equation has logs on just one side, then you just solve it with reverse PEMDAS. So I've got this example here, 3 times the log of base, and don't forget, when there's no base written for your log, it's really base 10. So this is base 10. So 3 times log of base 10 of 2x minus 4 plus 1 equals 7. So the first thing I want to do is see if I can simplify either side. So if I can combine like terms, or if I can combine logs together, anything like that, I want to go ahead and take care of it. And in this case, there's nothing I can combine here. I have a multiplication, I have a plus 1. Those can't go together, so I'm done with that. There's nothing to simplify. Then next, I want to add or subtract to cancel anything not in parentheses. So leave the 3 alone for now, because since it's being multiplied, that's part of this step. Instead, I want to get rid of the 1. So let's subtract 1. Awesome. And then multiply or divide to cancel anything not in parentheses. So I'm done adding and subtracting. The only thing left outside parentheses is this 3, and that's multiplication because it's 3 times the log. So to get rid of that, I have to divide by 3. So that leaves me with log base 10 of 2x minus 4 equals 2. And then what I've got here looks like this, and that's what you're trying to get to. You want this to look like this. So you've got your base, your argument, and your exponent. So I'm going to go ahead and highlight that. So I have my base 10, my argument 2x minus 4, and my exponent 2. So once you get your equation looking like this right here, then you're going to go ahead and convert it to exponential form, because that will get this part all by itself. And then you can work to get the x by itself. So I'm going to start with the base. So match up the colors. It's base 10 to the power of, and my exponent is here, it's 2. And then equals the part in yellow. 2x minus 4 is the argument. And then I forgot to write this here in the instructions, but 10 squared is a number. You can simplify that. So that right there, 10 squared is 100, equals 2x minus 4. And then you can add 4 and divide by 2. And then you want to make sure you check for extraneous solutions, because log equations can have extraneous solutions. So please do this. Just plug your value back in. And honestly, if you just plug it into the log part and make sure that you don't get undefined, that's plenty. But if you want to just be double sure, you can plug it back into the whole thing. So let me show you that. So I'm going to take 3 times log, and you can put the 10 or you can not put the 10. That's your choice when it's 10. And then instead of x, you're going to put times 52. Oops, and then minus 4, and plus 1. And then we're going to see if that comes out to 7 or approximately 7. So it came out to exactly 7 because our answer didn't have any rounding, so we're good. So that's an actual solution. Yay! So we are going to try one more, and then you're going to try the others yourself. I'm going to point out something here though. So example 3. So don't forget, ln is basically log base e. So when you see ln, it works exactly the same way as all the others, but it's base e instead of base 2 or instead of base 10 or something like that. So first, is there anything that we can simplify other than writing log base e? So I don't see anything that I can combine together. So let's go ahead and do reverse PEMDAS. So start with add subtract. And it looks like I can add 4 to cancel that out. So log base e of 3x equals 11. And then I want to multiply or divide. And there's nothing multiplied out here. The only multiplication I see is in the parentheses, and I can't do that yet because that's in the parentheses step. So I'm actually done with that. So now you'll notice my equation looks like that one or that one there. So it's log with a base, an argument, and an exponent. So log base e, argument is 3x, and then exponent 11. So let me highlight the parts. Log base e. Argument 3x. Exponent 11. So I'm going to then convert that to exponential form and try to zoom out. I think that's going to be harder for you to see. I'll try it. I can kind of see it both now. So I want to start with my base, so base e, and then to the power of 11 equals 3x. So e to the 11th power equals 3x. Let me zoom back in. Okay, so there you go. So e to the 11th power. Now I know that's a letter, but remember that's not a variable, that's a number like pi. It has a set value. So you can find it here, e to the x. So e to the x, and then to the power of 11. This one you're going to have to round, so let's just do 3 places. Let's round it to 0.142. Awesome, so that's done. And then my last step is anything that was in parentheses, so I need to divide by 3. So let's see what we get. So 59874.142 divided by 3. So that's our answer, and I'm gonna round it to 0.047. And then make sure you check it. So this time we are going to end up with a rounded result because we rounded our x value, but it should still come out close to 7. So ln is right there. So you can press the ln button or you can press the log button and then do base e. It's really your choice. I'm going to go for ln though. So control e to the x, that's ln. And then 3 times my value. Just going to do that. And then minus 4. And it does come out to about 7. Again, we did round the x value, so we should expect some approximating on the answer, but that's close enough. So we got it. Yes, it is a true solution, not extraneous solution. So you are going to try 2 and 4, but I want to point out something here. So remember the negative is really -1 times log base 2, etc., etc. So -1 times that. So remember when you get to your multiply divide step to divide by -1. Okay, so go ahead and give those a shot and then come back to check. Here's what example 2 should come out to. So negative 2.96875. And when I checked my answer, I put the full thing, so I didn't round it this time because it's only 5 digits long. I put the exact thing back into the equation for x, and I got exactly 3. So I do know it's a true solution, it's not extraneous. And then remember when you convert your log to your exponent that you have base 2, exponent negative 5 equals x plus 3. So there's that one. And then example 4, remember that if there's no base written, it is automatically base 10. Assuming the word log is there. Now if it's ln, it's base e, but if it's log and there's no base, it is base 10. So then you're doing 10 to the power of negative 2 equals x minus 1, and you get x equals 1.01, or 1 1/100th. And when I plug that back in, and again, I did not round it because it's a fairly short number, and I do get exactly 3. So that's a true solution. It is not extraneous.